Hello everyone, my name is Nidhi Chappelle and I am the head of product for Azure HPC and AI. I'm excited to join today with RocketML team to talk a little bit about Azure and our offerings in HPC and AI space. The way I've structured my conversation is I want to start off with why HPC in cloud makes all the sense. And I'm going to start off by comparing and contrasting with what exists on-premise today. I will spend majority of my talk giving you a primer on Azure's offering for HPC and AI and why I think the scalability and elasticity that cloud brings to HPC makes all the sense. I hope you find this conversation useful. Before talk a little bit about what Azure has to offer, I want to start off with the problems that exist with on-premise infrastructure. As you all know, when we have a big on-premise infrastructure deployments, our IT and sometimes our HPC procurement teams spend a lot of time understanding what are the requirements of the workloads and planning for these requirements as they are buying an infrastructure that they hope would last for at least 5 years. What happens with this infrastructure is, despite good planning and good effort from all the teams, the infrastructure pretty quickly becomes too small. The infrastructure pretty quickly becomes inflexible, not able to meet the requirements of the workloads that are constantly growing. As a result of that, too often we see our researchers waiting in long queues or just not having the latest and greatest. Especially if you are working with GPUs or that you have a very compute intensive workload, you want the latest and greatest from Intel, AMD, and NVIDIA. And this is where I do think the paradigm of on-premise HPC starts to break. When we look at cloud is actually able to address some of these problems, especially I think the cloud that we are building. At Azure, we are building purpose-built infrastructure. In fact, I would just say, if you were ever allowed into any of our data centers, not that you would be, but if you were allowed in any of the Azure HPC data centers, you will realize it looks very, very similar to what exists in any of the supercomputing sites. This is because we spend a lot of time building infrastructure that is very optimized for HPC. What it means for our customers, though, is since we own the infrastructure, you can actually scale up and scale down resources just based on your requirements. And you're not encumbered by this legacy infrastructure that sits. You're working on the latest and greatest genomics research, and you want the latest and greatest GPUs. Sure, you can light that up. And you can integrate AI into your workflows very quickly. So in short, cloud actually can provide the elasticity that you're really looking for. Now, as we look to cloud, there are some very common questions that our customers tend to ask. A lot of these circle in 4 key buckets. There is an element of, would I have the level of scalability? What about my workflows? Could I trust cloud? What about my future goods? And I want to show how all of these concerns are addressed in Azure. Let me take this one by one. When you think about scalability, one of the common concerns I hear from customers is, what about infrastructure that I need at scale? So especially think about GPUs. Like I was telling before, a lot of our customers have very hard time buying a big cluster of GPUs on premise because it is not very cost effective. You use GPUs for training for a short period of time, and then you cannot use this as effectively. So from a cost point of view, it's not scalable. And it's the same thing for HPC. This is where our infrastructure is really helpful. What we have done is we have built purpose-built infrastructure that are very much optimized for memory-bound HPC workloads, or compute-bound HPC workloads, a special set of infrastructure for high-end AI training, for AI inference, for visualization. And what that means for our end customers is you don't have to optimize for the lowest common denominator. You can now be selective of, based on your workload requirements, what infrastructure you can buy and what infrastructure you need to use. But what about cloud support? Would I be able to do any of this at scale? Yes, you can. You can actually do this at scale today. And this is where we have worked very extensively, because we know the transition from on-premise to cloud is a long journey. And we have focused very much on building that workflow agility. So if you want to just burst into the cloud and do your jobs at scale at cloud, or you want to move the production workloads to cloud, the workflow has been built so that you can easily and seamlessly move this from on-premise onto cloud. What about trust? Can I trust? And would I have control? And I think that's a common question that I get from customers all the time. Later in the presentation, I will talk about trust and security more, but I can assure you that we have built enough reliability and security in our platforms so to make sure that you have world-class platform experience. So you don't have to worry about accounting. We provide a lot of control so you can make sure there are no overages, that you can track the budget at a job level, at a subscription level, at a user level, so you can have that level of control. What about AI? And there's a lot of conversation of AI getting integrated. This whole conversation is focused around that. And this is where I do think cloud really outshines, especially within Azure. We have a lot of AI teams internally, Bing, Office. We take a lot of those learnings to optimize our infrastructure, and we make it available, like I was talking about before, in infrastructure that is highly attuned to GPUs and to AI workloads. And all of those infrastructure is very much available for our end customers. As an example, I want to showcase that, a year and a half ago, we published some of these numbers. Today, not only can we run highly complex jobs, 80,000 cores in a single tightly coupled job, we can have customers that have run 1 billion cell models. And a lot of these are because we have such optimized infrastructure. So like I was saying before, we have infrastructure that is very much optimized for solvers that are very compute bound, or for applications that are very memory intensive or memory bandwidth bound. In fact, as we compare with what is available on premise, which generally customers tend to be a generation behind, we sometimes can offer up to 45% better bandwidth, all because we showcase the latest and greatest. And ultimately, because you are on the latest and greatest, there's a lot of efficiency you can gain from not being encumbered by the fixed infrastructure. And there is cost reduction because you are able to get your jobs done faster and earlier because you have the latest and greatest infrastructure. Just tying all of this to the conversation I was having before is, not only have we built purpose-built infrastructure, but because we have a deep understanding of our workloads, we know how much the backend network, the fabric that connects the GPUs or the CPUs is important. So we are the only cloud provider that actually has significant investments in state-of-the-art InfiniBand interconnects. And the reason we do that is because we understand that a lot of our jobs, especially the jobs that are MPI jobs, require that performance. Increasingly, we are also seeing large-scale AI jobs needing that IB backends. In fact, you will see a lot of publications from Microsoft on natural language processing models, where we have models that are billions of parameters. And one of the findings that we have from these large-scale models, from training these large-scale models, is how sensitive they are to communication, inter-node communication. And this is where our investments in IB allow us to have a level of performance that is just not available anywhere else. beyond just the compute and the fabric, we know how important storage is, all of this. And so we have a wide variety of storage offerings, from very simple, that is very much optimized for throughput kind of workloads, to complex storage needs with parallel file system support. And then on top of all of the infrastructure, we provide end-to-end workload orchestration. So you can take your jobs on premise and can decide to actually run it in the cloud or actually move it onto the cloud permanently. And to tie it all, you can then integrate some of the services that are available in Azure to pretty quickly drop in AI modules into your existing applications. Not only do we have infrastructure that is highly attuned for HPC and AI, which is what we call our H&N series, we also offer a wide variety of infrastructure for different levels of compute scale. So a lot of our times, our customers will come in and say, I don't need tightly coupled jobs. And a lot of our customers, especially in financial services space or molecular dynamics space, tend to run on general purpose workloads. And we are totally okay with that because we provide the latest and greatest from Intel, NVIDIA, AMD in these spaces too. And then we also have customers that are on the very other extreme of this, where they're looking for supercomputers to be rented. So we do offer great supercomputers in the Azure premise for specific customers. Talking about storage, again, we have a wide variety of storage from depending on the use cases that come from. And this is, again, you don't have to think about your storage requirements as a fixed asset. In fact, I generally joke around that, the move to cloud is like learning a new language. One of the big challenges that we have for customers is understanding your storage requirements. People have decided that they have to have the most storage requirements and sometimes will over provision storage because they are really planning for the future generations. But in case of cloud, you really can think differently. You can think about per workload or per specific job, what is your storage requirements? And you can really capitalize and reduce the amount of the storage that you need, because you don't have to hydrate all of your systems. You can decide if you want to have some data that you want to keep it in hot caches, and something that could be not that you need it, and you could go for a cheaper blob storage kind of a thing. And it's really interesting because of these storage options that you can weave, you can stitch together on the fly. Customers are really able to optimize the cost points differently than what they can do on premise. And the other thing that you have to think about is the network. Again, like I said before, we have the biggest network for InfiniBand, but beyond just having the network that is the InfiniBand, we also provide express routes connecting different locations. So you could have your storage in one location, or you could have your compute in different locations, and you're able to connect very quickly to these through our express routes. Later in my presentation, I'll talk about how Microsoft has data centers now worldwide. Any given day, and this number is probably old by the time this presentation reaches all the customers, but any given day you will hear from us that we are in greater than 61 regions worldwide, and these are all connected through an express route. So you can actually have connectivity to all of your infrastructure worldwide on a very resilient enterprise grade network. And this is why we have customers anywhere from automotive, financial services, energy, silicon, manufacturing, or life sciences. Some of the common use cases that come around is customers in the automotive space moving from physical design to actually everything being digital. And they really want to move to a place where they can simulate every aspect of the vehicle engineering. To customers in the EDA space, where they want to have fine-grained control of their 5 nanometer, 3 nanometer changes, and they're really looking to actually see how they can run multiple scenarios in the cloud quickly. Or you may have customers in the oil and gas space where they're looking at both seismic and reservoir simulations, simulations that require a lot of data and a lot of compute, and they're moving it effectively into cloud now. So why Azure? Like I said before, not only do we have the most optimized infrastructure because it is optimized for HPC and AI, I actually do also think it is important for customers to understand that now we can actually be present globally. So if you have distributed research team, or if you have distributed teams that have local presence in different continents, we actually can make compute available to those local teams. Not only can we make compute available to the local teams, we can actually make that compute available through a very secure manner. In fact, Microsoft spends a lot of money per year just on CyberWatch. We want to make sure that we provide infrastructure that is very secure. We have around 3,500 full-time security professionals that are always looking out for cyber threats or cyber crimes. Beyond that, we also have data centers, like I was joking before, if we could ever allow you, but we have restricted access and around the clock monitoring of our data centers. All in all, we want to unencumber our customers from the needs to watch their data centers, the needs to watch their infrastructure, and we take that load off of them so they can actually focus on what is important to them, which is research, which is finding the next generation of cure for other things, and really things that make HPC so exciting. Here's a classic example of what our customers can do, and this is one of many examples that I could talk through. This is an example from climate domain. Again, weather simulations are such compute intensive applications, but we have a customer here, Mott McDonald, which actually wanted to make sure that they could run their simulations, but they had very limited on-premise infrastructure, which sometimes jeopardizes their delivery timelines. So we worked very, very closely with them to make sure how they could send some of their jobs onto cloud. And they wanted to use their existing infrastructure, but create identical resources on Azure. And we worked with them so they could decide when they want to have the jobs run on premise, when they wanted to actually have those run in cloud, and what would govern those jobs on the cloud. And they were able to run a lot of these jobs and get unique requirements, unique insights that they couldn't get before. Overall, despite a common presumption, actually they were able to reduce costs because they were able to do processing things on the latest and greatest, and sometimes get savings because they were able to run larger models that they couldn't do before. And this is one common example of many customers where customers are constantly able to get cost savings because they are able to bring products to market earlier, they are able to run scenarios that they couldn't run before, all because they are now using the power of cloud, the elasticity of compute that is available, that is not available to customers on premise. I know I covered a lot. I apologize if I ran through this quickly. I know there's a lot to cover. I encourage you all, if you are interested to learn more, to do connect with us. Whether at supercomputing, or here are some of the links that are available that will give you some more insights into the products we offer, the solutions we offer, and our unique work that we are doing with Rocket ML specifically. And all of these are public resources that are available to everyone. And I encourage you all to spend a moment to go through these and see if any of these would resonate with you. Thank you so much for the time. I really appreciate it.